Hello everyone, my name is Mario Meza. As a member of the technical support team here at InSource, I want to thank you for taking the time to join me as we take a look at the Historian SDK. In today's discussion, we'll walk through installation and review the sample projects that are included with the product. We'll establish a connection to a remote historian from a sample app and from a standalone project. From there, we'll discuss how simple it is to take that standalone project and convert it to an OMI Orchestra app or a .NET control for use in an industrial graphic. Finally, we'll import the SDK for use in a Galaxy. Before we dive in, I want to take a moment to cover a few things. First off, what is it? Well, SDKs in general are software kits that allow you to build customized software components. While an API may be likened to pre-made building blocks, an SDK can be likened to a complete workshop where all tools are made available to you. In a workshop, you have the actual tools for constructing something unique and are not limited to something that was previously made. Similarly, the Historian Software Development Kit is a set of tools that provides programmatic access to the historian. It does this by exposing methods or functions for most of the historian features, such as data historization, storage retrieval, tag configuration, connection management, and miscellaneous housekeeping tasks. The Historian SDK was the only toolkit to receive an update in 2020 and is based on a .NET version of the Historian Client Access layer. It can be used from either a standalone .NET application or within Orchestra scripts. So what can you do with it? Well, the SDK allows you to historize both real-time and old data. It supports full store forward for real-time data and inserts and updates for old data. Additionally, you can specify the data quality or OPC value from a client application. It allows for data retrieval by bypassing the OLEDB provider level and goes directly to the historian retrieval service. So using the SDK for retrieval is expected to be faster and more efficient than retrieving the same data from Microsoft SQL Server. The trade-off is slightly less functionality with regard to filtering and joining data. The results of any retrieval request can be returned to a client as a collection or one row at a time. Since all tag properties are available to an SDK client, you can add, modify, or delete manual tags. However, tags that were generated by application server can't be deleted by the SDK, and only a single tag can be modified at a time. Finally, with the SDK, you can perform a host of housekeeping tasks, such as obtaining a list of history blocks, creating a new history block, obtaining server-side settings, validating the status of the historian, such as has it started, are changes pending, what's the storing forward status, are commits allowed, and so forth. A solid understanding of historian concepts will be key in using the SDK effectively. So before using the SDK, it would be best if you were familiar with the following topics: tags and properties, tag storage rules, such as delta, cyclic, and forced, retrieval modes, such as delta, cyclic, best fit, counter, and so on, data categories, such as original, revision, streamed, and non-streamed data, historian client access architecture, including components such as HCal and HCAP, store and forward functionality, and event storage and retrieval. Just a couple things to be aware of before we get started. The SDK itself does not do any processing of any data. All storage rules are applied at the historian. It's possible to limit the type of access provided to a client application to one of two types: either read-only access, which allows for historization of real-time data, but does not allow any actions that change the state of the historian, such as tag modifications, history block creation, change commits, etc. And the other type, which is full access, which allows for the running of any action available in the SDK. This access requires that the user under which the SDK runs is a member of the local administrator group or the AA administrators group. By default, store and forward is disabled. The client application must enable store forward upon server registration. So first things first, where do I get it? The Historian SDK is available for download from the AVEVA site. From Product Hub, if we search for SDK, we should see the most recent version of the product. You have two options to download. One is the zip and the ISO. We'll be downloading the zip. Once the download completes, you want to remember to unblock the download to avoid complicating the installation. To do this, right-click, go to Properties, select Unblock, and now you're free to interact with the file as you are custom. Installation is pretty straightforward. Once extracted, launch the executable as administrator. Select the product you want to install, keep the default folder, agree to the license term, and install. That's it. Once completed, the SDK will show up on the system like any other installation package. Here we can see it in the list of installed programs from Control Panel. By default, the SDK and the documentation is installed at Program Files, Orchestra, Toolkits, and Docs. Here you see the README and a help file that covers the SDK in detail along with the sample applications that get installed with the product. We'll want to set this aside for later. Those sample applications are installed at Program Data, Orchestra, Historian SDK 2020 R2 samples. Here you'll see two sets of examples, step-by-step samples and a UI sample. The step-by-step samples are a set of 15 console applications that cover the concepts outlined in the documentation under Writing Your First AVEVA Historian SDK Application. For today, we'll be using Visual Studio 2017 and AVEVA System Platform 2020 R2 to take a look at both. They were built against .NET 4.8, so you want to make sure this is installed. Let's start by taking a look at the step-by-step examples. Navigate to the .sln file, which is the solution file. Double-click, and it'll open Visual Studio. Once the solution has finished loading, we'll select Step 1, Open Connection. Right-click on that project, and select Set as Startup Project. Now, for these console applications, certain values have been hard-coded. For a successful connection, we need to provide the username, the server name or IP address, and the password. Once these have been updated to match your environment, we can select Start from the toolbar at the top. Sometimes you get this, it's okay, the project needs to be closed and then reopened once the values have been updated, and everything should work. If a connection was successful, we'll see the output in the console. Here we can see that the connection to the server is true, connection to server storage is true, and store forward is equal to true. If we head over to our Historian and look in the Clients section, there's a couple things to note here. The application is named as Open Connection because that's the name of the console project. You can see the computer name from which we were connecting, and the user under which the client application is running. Let's head back over to Visual Studio and set Project 2, add a tag as the startup project. We'll close this down, find the project in the list of projects, right-click and select Set as Startup Project. We'll select the program.cs. This time, in addition to updating our credentials, the Step 2 application will create a tag named MyIntegerTag5. I just want to point something out. In the Step 1 application, everything was in the main method. Step 2 builds upon this and abstracts some of that functionality into two other methods. 1, open connection, and 2, close connection. In the main method, we see here that myIntegerTag5 will be created if we run this application. If you wanted to update this, there's 3 locations in the project to do that. We're going to keep the defaults, but before we start the application, I want to go down and uncomment the console.write line on line 133 and 134. This will allow us to keep the application open once it's running. Now, one other thing. In this application, messages are written to the console using the console.writeLine method. But if, for instance, you wanted to write a message to the orchestral logger, we can do that from the Historian object before we close the connection. So if you see here, Historian has a log message function that takes 3 parameters. The first thing we have to specify is the message severity, which in this case is just informational. The next parameter will be the string message we want to write to the logger, and then any errors need to be prefaced with the out keyword. Now we're ready to run the application. So we'll select Start from the toolbar. Like the previous example, the status is written in the console. We see that server is equal to true, server storage is equal to true, and store forward is equal to false. We'll press X to continue, and we see that myIntegerTag5 was added successfully. To validate this, we'll head over to the Historian. As you can see, add tag is listed as one of the applications because that's the name of the project in Visual Studio. If we look at manual tags, we'll see that myIntegerTag5 was created. Back in Visual Studio, if we press any key to continue, that message that we added will be written to the logger, but it'll be written to the logger that's local to the system management console where the application is running. So we'll open up SMC, look at the local logs, and we see this message that we specified in the application. We'll shut this down. Each project in the solution follows a similar workflow and builds upon the previous example. While we can't go through every example right now, leveraging these strategies, we can quickly get a basic application up and running in a relatively short period of time. Let's close down Visual Studio and take a look at the UI example. In the UI example folder, we'll locate the .sln file to launch the solution. Close down some of these applications. This solution is made up of 5 projects. The one we're interested in is the SDK named WPF. So we'll collapse the other projects. And like before, select that project, right-click, and set it as a startup project. To execute it, we'll click Start. If you see here, this application is a little different. It has a user interface where we can specify those pieces of information that were previously hard-coded. So we'll enter our server name, the username, and our password. When we click Connect, we'll see that the UI updates to reflect the current connection status. We're connected to the server, we're connected to storage, and we're connected to store forward. There's a few different tabs here where you can add tags, add values, and retrieve data. The help file has great walkthrough on how to use this application. If you go to the help, look up sample applications, you see there's a detail on what this application can do and how to use it. AVEVA samples are pretty solid, so here I'd like to take a bit of a detour and talk about the technology AVEVA used to build the UI example. That's WPF. While WPF is an entire subject unto itself, this is a great opportunity to share why it's still worth taking a look at in 2020. By using WPF and XAML to create a standalone .NET application, with minimal effort, you can convert it to create an Orchestra app for use in an OMI application. With the help of the element host control, you can again, with minimal effort, take that Orchestra app and host it in a .NET control for use in a Galaxy or standalone InTouch. So let's close this down. To illustrate this, I made a very basic WPF application. Now, it's in no way a polished application. The samples provided by AVEVA simply can't be beat. But there's no substitute for getting your fingers dirty and dealing with a bug or two. So, if you don't mind, let's take a quick look at it. The main application is of type WPF app. You can think of it like a next generation WinForms app. By that I mean when you right click on a solution and add a project, you can select the project type. This project is of type WPF. That's a standalone application similar to the main UI example provided by AVEVA. Now with this application you can open and close a connection to a historian, create or delete a tag based on the selected tag type, create or delete a list of tags in a CSV, or log status messages. Well, just so we can see that it's working, let's set it as a startup project and select Start. Here we'll type in our server name, and we'll open the connection. If this works, we should see some output. And we see that it's connected. If we look at the historian, we'll see that it is indeed connected to the historian. Okay. Now let's talk about WPF apps. WPF apps use XAML to build the UI. It's like XML or HTML in its structure, but without going down a rabbit hole. In WPF, there are a number of different controls. If you look, in this example, the window object is in the topmost of the hierarchy. It's a type of control called a content control. Now, content controls can contain a single object. So, what does this mean? If we switch over and look at the UI example, we'll see the same, that the window element contains a single grid, and that grid, however, contains many elements, which are all the controls that make up the interface. Okay, so what does that have to do with the SDK? Well, by adding another project to our solution of type WPF user control library, we can take the same work that we put into this main window standalone application and place it in a user control library for use in OMI. In fact, OMI apps are WPF user control applications. So, if we look at this project, WPF user control, which again, if we add a new project and select Windows Desktop, we have the option to select a WPF user control library. And when we look at this XAML, we'll see something similar. Instead of a user control, though, instead of a window, we see user control is at the topmost element, and it, coincidentally, is also a content control. So we can take everything that we put into the main window here, and we can copy that and place it in a grid in our user control. And with that, we're done with the UI. So we can take that same work that we put into our standalone application, and because the window and the user control XML elements are just containers, we're done with our user interface. If we look back at our projects though, there is a XAML.cs. And that file lines up with the same main window XAML.cs as well, with the only major difference being the constructor. So here, instead of main window, in the user control, we see that it's a user control. But that's pretty much it. That means we can take the code from our previous app, making sure to leave the user control and main window methods alone, respectively. And that's it. Now we can't debug this project in the same way we did previous projects since it's of type library. But if you want, a simple option is creating a blank WPF app and then adding a reference to this WPF user control library. But that's a different topic. Let's keep moving along and build this project in release mode. To do this, we'll just change from debug to release. Right-click on the solution and either build a solution or rebuild our solution. Once this is complete, we'll select the WPF user control, right-click, and open the folder in File Explorer. We'll go to Bin, Release. We're going to copy this release directory, and we'll just paste it right on the desktop. We need to put it in a location that's accessible from the IDE. We'll close this and minimize Visual Studio, and we'll launch the Orchestra IDE. We'll connect to our Galaxy. Once this is loaded, we'll expand the graphic toolbox. These are all the Orchestra apps that come by default with the installation. Before we import our application, there's one thing we want to do, and that's change the name of the directory to something more meaningful. Once we import the application, it'll take on the name of the directory. Now, to import the app, we'll just select Import and Orchestra Apps. Browse to the directory and select the folder. And that's it. The import is complete. We should now see our Orchestra app listed amongst the other apps. Now we'll open up our OMI instance and place it in an available pane. From the toolbox, select whatever we named our Orchestra app, place it in the pane, and when this finishes, we'll put it in preview mode. This should look familiar now. Let's give it a test. And the connection is successful, so we'll go to our Historian, and if you see here, we are connected from the view now with that SDK user. And so just like that, we've created a standalone standalone SDK application, and we've converted that to a WPF user control for use in OMI. But what if we aren't using OMI? What if I just have standalone InTouch? Let's close this down and take a look how we can do that with the help of another control called the Element Host Control. Let's head back over to Visual Studio. Just minimize this. Now the control I want to talk about, or the type of project, is a Windows Forms control library. So when you select a new project, select Add, the type is Windows Forms Control Library. And that will create a control like any of the other client controls that you're familiar with in the Orchestra IDE. So when I created this project, the first thing you want to do is add a reference to the WPF user control. You do this by adding a reference and then selecting that project from the list of projects and selecting OK. What this does is when we open up our control in our toolbox, on the left, where all the other controls are, buttons, text boxes, combo boxes, checkboxes, the like, your WPF user control, or the project that you created over here, will show up. There's this element host control, which you can drag to any Windows Forms project, and it'll allow you to host WPF controls. It acts like a container, and so that's what we do. You don't have to manually add this, although you could. It's done for you just simply by dragging and dropping that user control here. Once that's done, that's it. We just want to build our project in release. Now, with the Windows Forms user control, you can put that in debug mode. We're not going to do that now. We're just going to build the project so we can move this along. We'll open up the File Explorer. We'll go to Bin, go to Release, and this is actually the control that we just built, this WinForms control library. We're going to bring the whole folder. We'll just copy, close this down, and shut down Visual Studio. And we'll place this in a location that's accessible from the IDE. Go to the IDE, select Galaxy, import, client control, and browse to that directory. When we select Open, keep the defaults, it should import the client control, and there it is. We see it in the list of all the other OMI apps. We'll drag this to a directory, and now, or a toolbox, and now it's pretty simple. We'll create a new symbol, keep the default, and we'll open it for editing. Now, if you're familiar with industrial graphics, this part's pretty straightforward. We're just going to select the Embed Industrial Graphic icon, and in that directory, we'll select the client control that we just imported, which is called WinForms User Control. We just kept it default. Select OK and paste. Now, what you'll see here is the controls usually needs to be resized, so we'll size it to fit. And there's one thing I want to bring up. You may notice the elements in the UI can get a little skewed at this point. You notice the letters on my discrete and the closing right side of the output window are missing. And that's because we have a few elements and a few containers here. And WPF has its own caveats when defining UI layout, which is not to be confused with OMI layout. In any event, this part may take a little massaging, just depending on how you lay out your UI elements in XAML, whether you used a grid or stack panels, dock panels, or canvas, etc. But that's another topic. We're just going to save this symbol and check it in. It'll work for now. At this point, it's like any other symbol. We just need to access our InTouch application. We'll open up just a sample window, and we should have our control available. We just kept it the default symbol 1. Here you go. This will always remain that different color until it's resized. I don't know why it does that. Again, we may have a little bit of massaging to do, but the control will still work. And that's basically what I wanted to show you here. So we put it in runtime. sure enough, it works. And if we go back to our Historian, you'll see that we are connected via the view. So I hope this has been helpful. There's one more way to use the SDK, and it's the preferred method, and that's from the Orchestra IDE. Let's shut this down, and we'll import the SDK for use in Orchestra scripts. Alright, to import the SDK, we'll go to Import, Script Function Library, and we'll navigate to C, Program Files, Orchestra, Toolkit, Bin, we'll get the 32-bit, and we're looking for .aaslib. That's the SDK. Click Open. We should get a confirmation that the import of the SDK was successful. Now that the script is imported, we'll have access to its members from the script editor. Let me show you what I mean. Here's an object that establishes a connection to the Historian. It's done a little different here, but as you can see, we're able to access that library, or the SDK. While there isn't time to cover all the caveats associated with establishing a connection from an application server object, I want to cover the major difference between the sample applications and an application server script. If we switch back over to the PowerPoint, I'll show you what I mean. Alright, on the left you see a C# program flow for a basic connection to Historian. I just want to point out, you're not limited to using C#, you can use Visual Basic, Delphi, JavaScript, or C++. But in the IDE, it's a little different. On the right, you see to establish a connection, we need to declare our variables and use the application object domain, or app domain. This is a virtual process that enables scripting access to common .NET objects. It's used to share the Historian state and connection across engine scans. We could spend a bit more time walking through this, but unfortunately we've hit our time limit for today. As I mentioned previously, the IDE is the preferred method of using the SDK to avoid scenarios where an application migration or upgrade is broken as a result of a dependency on a DLL or fancy app that we create. My hope, however, is that after working through the sample apps and getting a feel for the program flow, establishing a connection via the IDE will make a bit more sense. A great example of this is available in the scripting guide on page 122. A detailed tech note will be available in the InSource Knowledge Center next quarter covering this topic. I want to thank everyone once again for sharing your time and hope you were able to gain something of value from this presentation. Wishing you the utmost success in your current or future projects. Have an outstanding day.